So I finally, for the first time in a while, made it through all of the pull requests. So uh, we've actually got a fairly up-to-date list now. And luckily, last week was the majority of the work since it had been a while since I'd done it before. But there were still a couple I'd missed that I needed to get in. So hopefully this is accurate now. So in the last week, nothing particularly new that I saw. If I screwed up, let me know. I didn't see anything. There were a number of pull requests that got closed. Those were all by the bot, from what I saw. Um, and there was an updated PR here. This one on the RGW side for D4N. Looks like that's gotten some updates. And Casey's been on top of that. Otherwise, lots of stuff from last week that hasn't seen movement. We had a large number of PRs come in related to RocksDB. I guess not a large number, just a few. But we should probably decide if we want to try updating to the most recent version, which is required for this file compression option. I do think I'd like to see some test results from that before we merge it, though. Otherwise, various other stuff here. There was one that we didn't talk about last week that I did notice. This is enabling 4K allocation unit for BlueFS. Adam here? Oh no, Adam is not here today. And neither is Igor. I did want to talk about that one to see what kind of effects that might have. But since they're not here, let's move on. There was also a PR from Igor about faster BlueFS allocation in the AVL and hybrid allocators. I glanced at that, but I need to look at that more in depth. I think Igor was hoping for me to review that, so that's on my list. Otherwise, I think we covered a lot of the new stuff last week. So anything I missed that anyone has, either new or updated, or anything people would like to talk about regarding pull requests? All right, well then let's move on. Luke, I see that you put a discussion topic in. Do you want to take over?
Yeah, I just we have a Ceph cluster where we're trying to optimize for performance, of course. So it's a great place to be on this call. So we in our last cluster we had we used RAID 5, and now we're looking to see what RAID options people have made use of. So we're in the kind of setup where we have say 200 boxes and each have 24 spinning drives and one SSD metadata drive, and just different configurations. We started playing around even with like three spinning disks, RAID 0 clusters. Just what have people tried as far as different even RAID 0, RAID 5 clusters, or just all spinning disks separate, and what are the implications with that with when you just have one metadata drive?
Sure. So it's been a while since I've done anything kind of real exotic. Back in the early days of Inktank, we looked at a lot of different things like this, where we were trying different RAID configurations and different replication levels. When, at least back in those days with FileStore, we definitely saw that the controller cache made a fairly positive difference in terms of performance, especially I think with the way that FileStore did journaling. It seemed like that helped quite a bit in terms of getting fast or lower latencies. With BlueStore, it's a little trickier, right? Because you've got your essentially your journey of the write ahead log on typically on the NVMe drive or on the SSD drive, and we actually saw early on that sometimes controller cache could get in the way. Uh, that happened on some earlier HP boxes, and actually I think we might have seen it with earlier LSI controllers as well. And I haven't looked at it since. That was like 5 years ago. So in terms of what's out there now, I'm afraid I'm not really up to date on what the state of the art is in terms of this kind of stuff. My guess would be that if you've got 24 drives and you've got one like fast flash device,
Right.
you may be bound by that device for write throughput, depending on the workload. Um, it,
I mean, our workload, I mean, we typically don't have a problem with our ingest and write speeds. I mean, that's not what we're necessarily optimizing for. So most of our heavy workloads are through like an S3, and most of our data is like say 30 megabyte Parquet files. And so we have
oh
different
wow,
different operations that are reading tens of thousands, hundreds of thousands of these rather large Parquet files from S3. We have other workflows, but I'd say that's our most demanding one.
sure, sure. So really, you're interested in like big streaming reads.
Right.
Okay, okay. Well, in that case, you'll have you'll still see probably the best performance using replication. Um, the the impact of having to do reads from different EC chunks on secondaries rather than just the primary is kind of rough. I mean, it if you're doing like if you're looking at 3x replication versus EC, it can be actually faster to do EC if you're doing big writes, but for reads, it's at least I've never seen it actually be faster to do EC with reads versus just always reading from the primary. So that's something to consider, I guess. Whether or not you want to do like RAID under an OSD, mm, maybe. I mean, what would you if you were going to do something like that? Were you just thinking RAID 0, or were you thinking like RAID 5 or RAID 6 as well?
So, I mean, we'll test a bunch of these configurations, but we're thinking both RAID 0 testing and RAID 5 testing. I don't, RAID 6, I don't think, I mean, just the extra layer, extra parity, disk, I don't think we're going to need, depending, so
Yeah,
RAID 0 and RAID 5 are mostly what we're thinking.
sure. And what you implement too. I don't know what vendor if you're going through any vendors for support, but they may have their own opinions on what they're willing to support as well. Um,
It's all
but
Dell hardware, Dell cards for the controller.
yeah,
Uh,
are you running community stuff, or are you like going through a vendor?
we're doing all this through Rook on our own Kubernetes cluster.
Oh, okay, okay. So it's like community stuff. So yeah, I mean, from that standpoint, whatever you guys are comfortable with, you can try. Um, yeah,
Well,
it'd be
would you
interesting.
expect a performance with like would you likely see the performance boost with underlying RAID or
I'm gonna guess that at some point you're going to be limited by the OSD. I mean, I don't know how fast these drives are, but if you're creating a big RAID under the OSD, you may start seeing that the OSD itself could be a bottleneck, but maybe not. I mean, I haven't tried it in a long time, so I guess I can't tell you. Um, you can do pretty fast throughput, like read and write throughput to an OSD backed by an NVMe drive. Like you can get 2-3 gigabytes per second per OSD pretty reasonably. Um, but having said that, that's a different device than a RAID full of hard drives that may or may not have other bottlenecks that hurt you. Um, it's possible that you may see better throughput by just you know using individual drives and doing like replication, kind of the standard way and stuff. But controller cache on the RAID array too can make a big difference. So I think the answer is I don't know. You'll have to try it.
And so, what do you expect the difference between EC versus just replicate? I mean, we've only for definitely for our S3 store, we've only our last cluster and this cluster we were only thinking of EC, but like, is there a big performance hit?
Well, you have to fetch chunks from the replicas, right? And you're breaking down the instead of having like say one big object. I don't remember how RGW breaks stuff down by default, but probably into like 4 MB chunks. Casey, is that right?
Yep. 4 MB abjects.
Yep. So you get your big like 30 MB Parquet file, like it's broken down into 4 MB objects. And then if you do EC on top of that, you're further breaking that down into separate chunks that then get distributed amongst the different OSDs, right? So instead of having like a big 4 MB object that you can read from just from the primary, now you're reading a local copy from the primary, but then you're going and fetching smaller chunks from other OSDs to recombine back into the object that you can give to RGW. So, the impact there depends on what the like highest latency fetch is from all of the secondaries. And that depends on network. It depends on, whether or not that other OSD was busy doing something else at the time. Whereas if you're using replication for reads, you can just read it from the primary and be done. So, it's definitely going to be some impact. How much impact? There's a lot of factors.
And I know you said you haven't done RAID testing in a while, but if we're primarily doing those kind of S3 reads as our biggest workflow, do we want to make the stripe size if we're rating like as big as possible?
Like in terms of the hardware RAID, this underneath
Yeah.
the OSD. Yeah, I mean that's what it used to be. Like for Lustre, right, and other things back in the day. If you're doing big streaming reads, you wanted to like both make the chunk size big, and you wanted to make the kernel setting for like how you like max sectors KB. I don't know if you've ever looked at that inside.
What's the setting?
Max sectors KB. Basically like how much you're breaking stuff down at the block device layer. For tuning RAID, you probably want to be like looking at that and looking at what the max setting that the device allows. If this is Dell, they used to use LSI. I don't know what they use now, but
I think under the hood the chipset's LSI. I think.
Yeah, I mean LSI doesn't like quite exist anymore, right? I think they got bought at least once.
Yeah, but I think like if you look at or maybe what it is that the at the OS layer it actually detects the chip. I think I seen D message something about LSI, so maybe Red Hat detects it somehow that way.
It used to be like the 2008 and 3008 were the cards I used to kind of remember testing on, but that was a long time ago. So yeah, I mean I guess the answer is I expect that if you do EC at the Ceph level, you should expect that it's probably going to be a little bit slower for this than just doing replication because of the extra work I mentioned. And if you do RAID, below the OSD, there's probably going to be some things that you'll need to tune there that are specific to the hardware configuration that you're running. In terms of the performance of that RAID setup, I mean, I would expect that it should be like a big fast hard drive, right? It's not going to be good at small random I/O, probably not as good as the disks individually. I would think, but the controller cache is going to have an effect there. So, lots of variables.
No, I appreciate that. So So we'll be playing with a bunch of different those parameters. There's lots of things to test, and it takes a little while to build up a whole test cluster with the different things. So when we're doing our testing and we're doing a bunch of reads, and ultimately what we get is we seem to overload the RGWs and start getting timeouts. Is that what you expect when you're like kind of stressing S3? I'll load 5 terabytes worth of data in these 30 megabyte chunks, and then try and read it as fast as possible. And basically, the more workers I have reading it, eventually I just start getting RGW timeouts, or at least that's what's read from the API at the application layer from like an S3 read. Are there good things to try and measure when I'm overloading the RGW, or good things to tune in this kind of setup where I'm doing a lot of large object reads?
I'm going to defer to Casey since he's the expert on RGW here. Casey, what do you think? What would be the next step on the RGW side there?
Well, my first intuition would be that it's just the bottleneck is reading from Rados, not a bottleneck inside of RGW itself, but it's hard to be sure.
Would the timeouts be, would that kind of go along with that, Casey, that it's not getting responses from the OSD fast enough, or OSDs?
I think so, yeah. A client shouldn't time out unless it receives no data at all for something like 60 seconds or whatever its timeout is. And RGW should be able to stream data, at least a byte in that timeout.
What I see from the RGW logs is like, say I'm doing a 5 terabyte read, that I start getting pretty good, what looks like pretty good read speeds for a little while, for 1 or 2 terabytes, and the latencies look good, and then all of a sudden I'm getting latencies in the 10-second range in the RGW logs, and then I start getting timeouts. But definitely for say that took 5 minutes to read 5 terabytes in the setup, the first couple minutes I don't seem to see any kind of timeouts or even like large latencies, and then just all of a sudden latencies shoot up in the RGW logs and I start getting timeouts.
How are you measuring the latencies? Are you just looking at
I'm just looking at the latencies in the RGW logs.
And that time's like how long a given request takes to complete entirely, right? And so for very large object reads, you would expect it to be pretty high, right?
Well, for quite a while, I'm getting sub-second, like 0.1, 0.2 seconds. And then it just hits some kind of something, and then all of a sudden it shoots up to 5 seconds, 10 seconds, and then I start getting, at the same time I start getting at the application layer like timeouts, which what's seen is from an S3 perspective timeouts.
Is it possible that the fast reads are coming from cache?
I don't think so. Just with the amount of data I'm reading, I'm trying to do that to try and avoid having a lot of cache.
Sure. Like the ones that you're reading are like the first ones that you wrote rather than like more recent stuff that you've written?
Right.
Yeah, okay.
Just any tips on how to diagnose it would be great too.
There was a comment in the chat window. I don't know if you see it.
I had not seen this article, so we'll definitely look at it.
In terms of diagnosing further, one thing that might be good is to try to see kind of what, if you can track down what's going on in RGW versus what's going on in the OSDs, like even at a surface level, what looks busy right? Is RGW really busy? Are the OSDs really busy? Um, is there? Can you kind of start isolating what's doing work? What? How many drives do you have total?
Each box has 24 spinning drives, 1 metadata.
And how many servers?
In our test cluster, we've got like 20.
20 of those.
Yeah.
Okay, pretty big. And when you see this high latency start kicking in, what kind of throughput are you getting aggregate?
So we're reading at about 20 gigabytes per second, and then we
Okay,
start. That's our aggregate read speed from our kind of test read cluster, our workers, and that goes on for say a minute or two at that kind of rate. Getting close to that, close to 20 gigabytes per second, and then we start getting read timeouts, and it drops to half that if it finishes, and if not, it's at the application layer at some point the timeouts are such that it won't finish.
okay. So 480 drives total, is that right?
Yeah.
Okay, 480 drives. What kind of networking?
Each box has 25 gigabit.
Okay. Okay. Trying
And I
to
think that
game
last
out.
test we had configured those as 8 OSDs per box with three disks in a RAID 0 setup. I think that last one that I'm quoting, each box was
Oh,
8 OSDs and each was a three disk RAID 0 array.
I see. I see. So, okay. Thinking about this, you've got 20 boxes, 25 gigabit networking, so you should be able to do trying to like around two. You do about two gigabytes per second per card per NIC. I don't know what your how fast those can go individually.
I mean, each NIC is 25 gigabit.
Yeah, I'm just wondering what realistically what you're getting like if you do a network test with those.
I haven't done, I guess that.
Okay, that might be worth doing. And we have seen situations sometimes where um, the switch looks good when you're doing like point to point tests, and then if you saturate it with like traffic from all NICs to all other NICs, then the switch kind of falls apart. Um, that in the past has been primarily due to like weird issues with the bonding configuration. I don't know if you're using bonding, but
We're not using bonding, but we're actually thinking about it. They're dual 25 gigabits, but we don't have the other port lit. So something
sure,
we could play around with is bonding that and having the two 25s bonded, but we haven't played with that yet.
sure. But okay, let's just assume that you can do like 2 gigabytes per second, and that is reasonable per NIC. So with 20 of those things, you should be able to do like up to like 40 gigabytes per second would be kind of what you'd expect the limit would be. So that's assuming it's working right. That shouldn't be limiting you, right? You should be able to do 20 easily.
Right.
Okay. So then I think, and did you say you said a three disk RAID 0 behind each OSD, and what was the Ceph configuration? What were you doing on that side?
Uh, what was the question? I mean, we have eight
Well,
OSDs.
replication or erasure coding?
Oh, erasure coding.
It was erasure coding. Okay. So you're breaking up that 4 megabyte object into multiple smaller objects, and then you're requesting the RAID 0 to service those. I wonder a little bit if the combination of VC and RAID is maybe not the way to go. Maybe you do try one or the other. and just
Oh,
see
we,
how
we,
how
we
it
can
works.
definitely play with that.
Yeah. And have you at all yet, or is it is
We have not played we've only tried erasure coding so far.
so maybe if you've got a test cluster to just play on, and you can create different pools with different Ceph replication or erasure coding factors. Maybe just don't redeploy everything yet because you've already got the 3 disk grade 0 ones. But just try a couple of different pools with different configurations, EC or replication, and see how that affects your results. And then at some point you may want to see, like if switching to just single disk OSDs, how that affects it.
I mean, we did some initial testing with single disc non-rated, but we should do some others. Like, I think there's a question whether to use the metadata drive at all with those or not. Just with if the metadata drive would be overloaded.
Yeah, I mean it's only going to affect your write path. I mean, if your primary
It only
workload
affects
is
your write path. Is that what you said?
yeah, exactly right. Like if well, that's not true. It is for the write ahead log. It's not for database node reads, right? So sorry, I that was a stupid thing to say. Um, it it primarily affects your write path in terms of the write ahead log.
Okay.
For the database itself, it's going to be writing out SST files or reading in SST files. So you're going to expect to see like bigger reads, which you may actually be better on the hard drive if you're only have one device per 24 hard drives. You're just going to have to see it's going to be I don't know, a complicated thing. Um, it might even be that you're better off like having just level 0 sitting on the SSD and then letting other things get fetched from the hard drive. But I don't know how fast. What kind of device is it that you've got for the fast device?
I mean, it's not NVMe, but it's a pretty fast SSD.
Okay. Yeah, tough to say. With just one for 24 hard drives, that's a good chance that you're going to be overloading that thing. But it
For reads, you think also though? I mean, it may be overloading.
well, That depends then on how much you have, how much cache you have per OSD. For
How much
reads, it just.
how much cache where are you talking about?
Do you know the OSD memory target setting?
And we have a lot of memory on these boxes, so we can configure it with more.
Okay, I would. So the OSD will try to self-tune its caches based on the target that you give it for memory. And so the big one that affects performance here is the onode cache in BlueStore. That's basically like an inode, but for Ceph onodes. And if you don't have enough onode cache in BlueStore to be able to fit all the onodes that you're working on there, then it will fetch from RocksDB, and RocksDB maybe will have to read an SSD file from disk to be able to fetch the onode that you need. So that would be
What's the parameter called that we want to look at?
OSD memory target.
OSD memory target. I would guess we're using whatever's default in like the standard Rook deployment.
Yeah, it's probably 4 megabytes then, or 4 gigabytes. Sorry, not 4 megabytes. But if you've got tons of memory, then yeah, you could absolutely bump that up. It's possible that it might try to auto tune that based on the memory in your node. I think there was something like that, so it's possible it's giving it more. You just should double check.
Okay.
Might be
There's
also
relatively for like the kinds of reads we're probably doing. I think anytime we're doing RAID, we're probably doing like 256 kilobyte stripes. If our basic read then is 4 megabytes, should we like get closer to that? I would think.
Well, it's not going to be 4 megabytes if you're doing EC at the Ceph level, right?
Oh,
Then you're
yeah.
going to be breaking that up into smaller chunks.
Okay. Another thing to
But if
test
you're,
both ways.
yeah. Sorry, someone else was trying to speak. Who was that?
Just me, Matthias. So it might be just perhaps worth to recheck on the single disk. Despite you have a limited amount of flash, but the amount of memory and the handling for larger OSDs might be more complicated than the smaller individual OSDs. So you have a lot of data backed by one OSD and then try to just suck in everything from this large OSD. Yeah, so it might be a bottleneck at the end with having multiple data just fed from different areas.
Okay, we'll try that. I mean, one thing that just to notice if there's a change, because our old cluster was running Nautilus, and even in that one we didn't have a separate metadata drive, and like when you do a LS block, you could see the metadata partition on each drive, but when I don't specify metadata drive here and I get 24 drives, I don't see like a metadata partition on each drive. Is that a change with Quincy? We're doing this on latest Quincy. Is it just you do it internally and you don't see it?
Sorry, Luke, I was reading Tyler's response in the chat window. Can you repeat the question?
So if you don't specify metadata drive, it just uses one on each of the regular drives. And I guess the reason I'm asking really is on Nautilus, when we did that, I think you saw in LVM like a volume that corresponded to the metadata on each drive, but I don't see that in Quincy when I do that. Is that just a difference in organization and it's doing it?
Good question. I don't know the answer to it. It's possible that they're organizing things differently. I'm guessing Nautilus might not have been using Ceph ADM, which Quincy I think is. But this is more kind of how like Rick is doing things, and I'm not an expert there. If anyone else wants to jump in, feel free.
And when we're playing with maybe 24 individual OSDs, is there any concern with the overall OSD count when we get that up to 200 boxes?
I mean, it's if you had 200 boxes with 24 OSDs per box, that's a big cluster. I guess the question for you would be kind of what are you thinking about in terms of how you manage all of this, and like the things I've seen in the past have been sometimes the amount of data that's being fed into the manager can be like a little bit overloading. You might have to turn down some of those settings. Other things like just the amount of information that's hitting the mons and the manager and other things can be something to pay attention to. I mean, other than that, people run big clusters. You might, I don't know if Dan comes to any of the users meetings. I think he does though, and that would be a really good place if Dan is there to talk to him about it, because they have very, very large deployments at CERN, and he can probably give you a nice description of what they've had to do to kind of manage at that scale.
Which meeting?
I think the size with 400 and a little bit OSDs is just a medium sized cluster. So the usual deployment for some common environments. So it shouldn't be a big deal. If you go far beyond that, so say 2000 or something like this, it might be more complicated. But still, it's there is case, yeah.
Yeah, as individual disks, it'd be 4,800 OSDs.
I think this was also the size that Kyle tested with in his setup and separating RGW on cluster RGW wise into different zones. And this was a deployment I think tested for 480 per um, zone area in the so subcluster, so to say. I think that's reasonable.
We've not played with any RGW zones.
And I just it's only just for the folks because SoCal Beta did some testing around how far you could scale. It was based on the older bits, so I think Nautilus still, but so there was some kind of performance boundary that's imposed by the RGW caching. But so this size, what they used, were I think 480 per subcluster. So you scale based on that. So it should be a reasonable size. What you do.
Joshua,
However, I'm sorry. Just I think I remember correctly. So 20 gigabits per second was something that was the upper limit that you could get out of such a set of drives. And just even if you scale it beyond then a number of RGWs could scale, but you don't want to get more, or you will not get more performance out of this basic setting. Yeah.
oh, uh, maybe a question for you, Luke. How many RGWs were you running?
We tried different amounts, so that's actually reminds me of a question. Like, what is the optimal number? We could run an RGW on each box. We could do, I think, for the 20 node test cluster, we had 8 or 10 RGW nodes co-located.
I don't know if there is exactly an optimal number. I mean, like, I can typically scale pretty well if I'm seeing that there's more capacity at the OSD level, throwing more RGWs in and having clients talking to different ones generally lets me scale farther when I've done testing like this. Um, are you trying to use like a load balancer in front of it, or do you actually have separate clients talking to separate servers?
We had separate clients talking to separate servers, load balanced evenly across the RGWs.
Okay, okay.
Like in my test read cluster, it's had like 400 workers that are all reading, and they're just each one evenly distributed across the RGWs.
Is that what you're going to do in production?
Yeah.
Okay.
Or I mean, we've tried different load balancing mechanisms, but basically load balanced across RGWs somehow.
Casey, do you have any opinions? I mean, I've just been usually I can get pretty good scaling with multiple RGWs, daemons, and clients talking to them individually.
Yeah, the that 8 to 10 number sounds perfectly fine.
Cool. Joshua, did I see?
What are some good mechanisms to understand whether it's the RGWs are being overloaded versus the OSDs?
So when you've got RGW working hard, it's going to use a lot of CPU. Like for large streaming read or write workloads, I can typically see that it's consuming a fairly large number of cores. I don't want to give you a number off the top of my head because it's been a
Yeah,
while.
in my test cluster, like I think there were maybe 8 RGWs, and I saw each one using 2 to 3 cores.
Okay. I mean, I pushed it harder. I've been able to get RGW to use more than that, but it depends on the particular version of the code you're using too. Um, how much, when you're getting that 20 gigabytes per second, how many RGW instances did you have running?
I think it was 8.
It was 8? Okay. You might be able to achieve that with fewer, possibly. I think I've gotten RGW to do more than like 2 gigabytes per second in aggregate before, but it's been a while since I looked at it.
I mean, we're just getting these timeouts, so I just figured, for now, like having more isn't hurting anything. Testing.
Yeah, and I'd be really interested if you did try with fewer, if it topped out lower, or if it if you had more issues with timeouts. Um, and that would be maybe a one way to start playing with and seeing what happens if you scale that bigger or smaller. If you've got 20 nodes to work with, I mean, you can run a fairly large number of RGW instances. You won't have memory issues. I mean, I've run like 4 RGW instances on the same server before, so I've done pretty big ones. But with 20 nodes, I mean, you could try up to 20 very easily. Joshua, I saw earlier. Were you trying to talk? I didn't want to.
All I was going to mention is at least at 2000 OSDs, we haven't had to do anything special with Monster Manager.
Okay.
Oh, thanks. Really appreciate all the comments and help. We'll try a lot of these different tuning parameters and different configurations, and love to report back in a future meeting on what seems to have worked and probably more questions.
Yeah, I don't know, like with 4,800, I don't know if that's actually how big of a cluster that is in reality these days. I don't typically get to test at that scale. So you're doing things that people do, but I don't. So, how Laura, how big is the our test cluster? Are just like tiny OSD one?
The Gibba cluster?
Yeah, give us. I can't remember the name off the top of my head, but yeah, how many OSDs
It's
do we
like
have there?
about a thousand OSDs.
Okay. So that's basically we've partitioned stuff up. That's I think our biggest in-house one that we test on is about 1,000. So 4,800. This is the problem in storage all the time. Vendors never have setups as big as the ones that users are building. So definitely would be interested in hearing what you run into. All right. Anything else, Luke, on that?
Not right now, but really appreciate all the input. Thanks a lot.
Yeah, no problem. No problem. And yeah, I would definitely encourage you to reach out if Dan's at the user meeting. CERN is a wealth of knowledge for anything like this. So he may have some really good advice. All right. The only other thing I was going to mention is that there's more work ongoing with the RBD mirror issue that we've been trying to get past. Adam started working on a new version of his shared blob code. Rather than having a single tracker now, he's trying to make it so that we can add new extents to an existing shared blob. And he's got code that works. We tested it out, and it's maybe not quite as impressive as the initial version of the one shared tracker was, but I think it's actually better than the fixed version of the one shared tracker. So in the chat window, I'll put a link to the latest test results. That's here for anyone interested. I also tested his latest version. This is this elastic shared blob branch overlaid with my defrag on clone pull request. And so the original is the blue line there. His work is the yellow line. The defrag on clone work that I did is the red line, and then the combined is the green line. And I know this is kind of hard to read. It's really kind of nasty. Maybe I'll actually share green, and I can just kind of point it out. Oh, I hate the way that they've got this now. Okay, is that showing up?
Yeah, it looks good.
It's visible.
I'm on the wrong tab here, it looks like. Okay, there we go. So, anyone see that? Oh boy. I wonder if this was a bad idea. Can you guys still hear me?
Yeah, we were seeing it.
Oh, you were? Okay. I didn't hear anyone for a while, so I was afraid this like broke.
No, we're sorry.
That's okay. Let me see if I can share it again then. Oh, now it's a different window.
Yeah, we can see the whip Atom BS1 shared tracker tab.
Yeah, let me switch it over. This is where it kind of got messed up last time, where I was trying to switch it to the other new test tab. Do you see that one?
New test, yeah.
Yep. So yeah, that's the gist of it is really that the combined work where we're doing both the defrag and the Atoms elastic shared blob looks like we get benefit from both of them, and they're additive. So that's kind of what we're hoping for, is that maybe by using both we can kind of make this better. The thing that we're still worried about though is that just getting snap shots and cloning faster may not be enough to make RBD mirror faster. We're gonna hopefully get this into Paul's hands soon, so he can try with his RBD mirror setup. But that's kind of the concern, is that this might not be enough. We'll see. So yeah, hopefully. And that's the only other thing I wanted to talk about today. So
just a quick note, basically a residue from the coursing, if we have time, of course.
Yeah, absolutely. Go ahead.
CRC32, fast path for ARMv8. I've taken a look on the implementation in RocksDB, and actually it's fully available. The question is whether we really pick it up. Let's start from our good old friend from similar x86 investigation. Here is the point where we are determining which exact implementation should be taken. And what should be, I guess, I don't know ARM too well, I guess it should be this one. Let me paste link to the fastpath. I think it's fastpath for ARM64. And a bunch of things, both compile and runtime. Might be worth putting a bunch of the bugs here. So first of all, we need to have the auto detection at CMake level fully operational. So let me pinpoint to an exact area. We need to ensure the flag is defined. I mean, let me paste. We need to have our IRM64 CRC defined. It comes from CMake, detection. And also another thing is the availability of get aux val. It's also checked by CRC. And finally, the hard kernel needs to inform us, needs to set this bit, select the proper CRC implementation. If any of those is false, it's not correctly working, then we are falling back to a slow implementation. But just to ensure, I understood that you saw those issues in RocksDB, because okay, we have at least two places that are interested about CRC52 calculation on the right path. First one would be okay, free messenger Bluester, but those parts of Bluester that are being executed by the OSD TP threads. And finally, RocksDB.
So the background for folks on the call, I got an email from Rama over at Amper Computing. They're trying to do some performance testing on their ARM CPUs, and we're getting lower performance than x86, and we're trying to figure out why. They did some wall clock profiling, and in the wall clock profile, it appeared that we were using the slow CRC 32 path rather than the fast path. So that's the background here. Just give me 1 second, Braddock, to find the right line.
Sure. Mark, just a note on that. It might be misleading. I recall from x86 that on some platforms it was in line in a way that in profiling somebody could get suggested that fast CRC is being used, while because of I don't recall right now, maybe some inlining, maybe other compiler optimization, but it was at first glance it was looking like fast algorithms was selected, but actually the slower one was in use. So might be worth to double check. Okay, RocksDB SCRC extent implementation. Looking.
Yeah, I don't know how.
I see. It looks the selection is here. That's the place for selection. Yeah. See, still the same. Have IRM 64 CRC, and also the same way CRC pmur runtime check. So basically, like the regions mentioned before, the same conditions to have fast CRC. Anyway, was it? How do we build? Well, what was the source of the packages, images, whatever used in this particular environment?
Great question. I have no idea.
Me neither. No idea who builds the ARM64 stuff. Is it Kafka
Yeah,
build?
it's Ceph Quincy on Ubuntu installed with Ceph ADM in containers. Okay, so that's what it is. It's whatever Ceph ADM does when you use it on Ubuntu. Yeah, I have no idea. I don't know even who builds that, if we do or if someone else does. I think we build it, don't we?
I'm not 100% sure. I think okay, for sure. I saw we have the make check bot for ARM64. I'm not sure it's an official platform.
Yeah. But that might at least partially explain some of this.
Yeah. Well, at least it's worth filling a tracker to not post this information. As well, RM it's rather rarely seen in our trackers.
Yeah.
Do we have any hardware for investigation?
I want to say that I thought we did have some kind of Emperor in the lab.
Yeah, we have to because otherwise no support for the make check bot for M64.
Yeah, Dan Mick has worked on it before, but I don't know anything about it other than that we have it.
more more burden with getting the hardware, the testing environment, than actually making a fix, I guess.
I don't even know if we can use that hardware for testing or if it's just for builds.
No idea. It looks like we will need to go to the main mailing list and ask. Maybe somebody knows.
Yeah, I'll reply back to Rama though, and just mention that we'd like to create a tracker for the CRC issue so that we can at least get into the system.
Well, might be worth providing them with the links. Maybe they are doing. Okay, I doubt they are doing custom build. I doubt that somebody would fix it for us.
Yeah, they said in this document I see now that it's Ceph Quincy on Ubuntu installed with Ceph ADM in containers. So I don't think they're doing a custom build. All right. Well, anything else, guys? If not, we used up the whole hour. So thanks for sticking around, and have a good week.
Thanks, Mark. You too.
Bye, guys.
Thanks.
Bye.